Hey everyone, we're live with tonight's session about books and lightning talks, and these are tonight's contestants, contributors, um, Nicola, Jonathan, and Slobodan, and myself, um, which will be basically tonight. Let me go back to the slides, and let's get started. So tonight we are going to listen and see about Modern C++ for Absolute Beginners, a book by Slobodan Dimitrovic. And quickly want to mention we had the job fair last week, and that was again a full success. We had one employer attending, and we're going to see how the job fair is going to go on in the next quarter in 2025. Conference, all three of us have been, or all four of us have been involved in the conference in some way. Nicola and Slobodan have been a speaker, and Jonathan has passed off my stuff and has been in Berlin. And I also have been at the conference doing lots of stuff. So if you want to get a feel for that on the conference side, if you go to the workshop, you still can get yourself an early access ticket for the videos. Quickly mentioning the code of conduct which we have, so please be respectful to each other, and if you have something to complain about, quickly send me an email. And with that, let's get started about this book, Modern C++ for Absolute Beginners, with Slobodan Dimitrovic.
Hello, everybody. Thank you, Jens. Thank you for inviting me to this meeting. Please allow me to introduce myself. My name is Slobodan Dimitrovic. I am a professional C++ trainer, and I'm also the author of this book, which is called Modern C++ for Absolute Beginners. But I like to refer to my book by its second title, which is A Friendly Introduction to C++. So please allow me briefly to introduce my book. My book is an introductory course to the C++ programming language, the C++ standard library, and modern C++ standards. In the second edition, I've included notable features starting from C++ 11, C++ 14, 17, and C++ 23 as well. So I hope you find this book useful, because learning C++ can indeed be a challenging task. So my idea with this book was to provide an introductory course to the C++ programming language, the one that aims to explain complex things in an easy to understand manner while not sacrificing the amount of info you should be introduced to when working as a C++ developers. So for the moment being, I'd just like to introduce you to learning C++. If a software developer or an engineer is left on their own when learning C++, it can prove to be a challenging task. So determining what is it that you need to learn right away and what is it that you can do without, especially in a complex language such as C++, can indeed be a challenging task. So hopefully you find my book interesting. Hopefully this task of learning C++, my book makes it that much easier. So in short, that would be a short introduction from my side.
That's nice to hear. But actually, there's one more thing worth mentioning, and that's you've been a speaker, and we wanted to do an interview. And so if you have any questions regarding the book or the talk, which was C++ for C developers, Slobodan also has given a training on this last week, then we can just do this now. And for that, let me just
Sure, sounds good. Perhaps I could share a few slides from my book, if you agree.
Sure, we can do that.
Okay, let's see. Let's share a screen here. And there we go. So a little bit of info about my book, how I structured my book. So first, there is the language itself, and determining what is the solid knowledge base in a language itself can be also a challenging task. So let's take a look at the table of contents. Here I have included some of the topics that I feel are the making the knowledge base of every both professional and aspiring C++ developer. So it goes without saying, first we need to start with the introductory topics such as types, declarations, expressions, operands, and then we build in complexity, statements, built-in statements. And as you can see, every few chapters, I've included exercises that grow in complexity. And I'm a huge fan, for example, of generic naming conventions, because I feel that gives you a solid ground to start working on your own naming conventions. Also, there is a question nowadays, especially in modern C++, there is this notion that we should depart completely from a raw arrays and raw pointers. So this was, for example, this was one of the topics I discussed with other developers as well. Should I include raw arrays and raw pointers to begin with? Now, there are two arguments for this. One that says you should completely depart from raw arrays and raw pointer in C++. But since I give C++ trainings to the industry, and 90% of the time I do indeed see raw arrays and raw pointers, so I felt the need to introduce raw arrays and raw pointers, if only to discourage their use in favor of better facilities we have in C++, especially in modern C++, such as smart pointers, more specifically unique pointer, which should be a replacement for a raw pointer. But I felt the need that you need to be introduced in this notion of raw arrays and raw pointers, if only to discourage their use in favor of standard library facilities and smart pointers. And then we build in complexity. There are statements, both built-in statements and user-defined statements, functions, scope and lifetime, which is a very important topic. And only then, when all of these topics are in place, do I think that we should tackle the topic of classes. So only when those topics are covered and we establish a solid base, then we can tackle the topic of classes. And then, for example, the question comes to templates. How much of a template is too much of a template introduction? So I kept it fairly short on the topic of templates, because I feel talking too much about templates can be overwhelming, especially for people who are just getting introduced to C++. So that's why I felt the need that only a brief introduction, I felt the need can be a beneficiary to you if you're starting with C++. And then we move on to the topics such as the standard library, smart pointers, standard library, notable containers, notable algorithms there. And finally, we talk about C++ 11, 14, 17, and 23 standards. So I hope you find this book overview useful, and I hope ultimately this book motivates more people to start learning this language. Okay, so that's that from my part.
I have actually a question which fits perfectly in this. Christian Freund asks, I need literature to get people on board with modern C++ that have worked only with pure C so far. Is that the right books?
I indeed hope that this book, you find it useful. I've written this book so that you don't have to have any prior knowledge to C++, shall we say. And if you're coming with a pure C background, there are things to, and moving to the C++, there are things to both learn and things to unlearn when starting with the C++. So with Meeting C++, we just finished the training that was actually meant for this. It was called C++ for C developers, where we talked into greater details about what are the paradigms we should adopt when moving from C to C++. Now, there are two schools of thought that say that you should learn C++ prior to C prior to learning C++, and that's not really true. I mean, I personally think that you are better off even if you don't have any experience with C to start with C++. But if you do have experience with C, that can be an advantage in a way that you already know a great deal of basic language facilities, as far as we keep this notion that C and C++ are two different languages with two different ways of thinking, two different programming paradigms. So I hope you find this book interesting as well.
Yeah, I think especially the training, and not forget that we had a talk. Let me bring up my slides again. We did have a talk which you gave, and is going into the same direction, where Slobodan talked about C++ for C developers and migration. So this talk is already on YouTube. If you want to take a look at it, there you probably have like also a different medium. And we had a training in the same direction last week with Slobodan, and we're probably going to bring this up again if there's interest. And then the whole book here kind of, is for beginners, but probably also like it doesn't really make you lose something when you already know something about programming from a different language, or like already are familiar with C. So
indeed. So if you can perhaps reach to Jens Weller, and if you're interested into this training, this is a 2 days training where we talk into greater details. It's an 8 hours a day training, so it is involved, where we talk indeed about things that are both similar in C and C++ and things that are vastly different in C and C++. So drawing the parallels between the two is often discouraged, but nevertheless, we talk about most direct equivalence and shift of paradigms is basically what we want to adopt when moving from C to C++, because in C, for example, we are used to working with raw arrays and raw pointers and pointer arithmetics. But in C++, for the most part, while we still can do that, we tend to stay away from such programming paradigms, because we delegate this task of manipulating raw memory blocks represented through arrays or pointers, doesn't matter, to some other facilities in C++. And C, for the most part, is a procedural language, whereas C++ can be both procedural, but most of the time it's object-oriented language. So yeah, we talk about those topics into greater details, especially in our training, which is organized by the Meeting C++. So something that you can potentially explore as well.
Indeed. And generally, the whole raw access is something I think which we probably will say goodbye to. And, this whole safety debate is also kind of, going into that direction.
Exactly.
So we'll see. Thank you, Slobodan. Let me continue in my slides, because here we are. Thank you for actually like all the support you have given to Meeting C++ this year, for the training, the talk, and being here today. Thank you, Slobodan.
You're most welcome, Jens. I'm glad I was able to help. Thank you very much.
And now let's continue with lightning talks. And you've already saw them, and let me bring them back again. We have Nicola, and we have Jonathan, and myself also will be giving a lightning talk now. And you see, we will be starting with Nicola. So please share your slides with us that I can switch that.
Can you see my slides?
Yes.
Okay, good. Shall I just start?
I think we're ready.
Okay, cool. Yes, so welcome to my talk about titled Use malloc to speed up your code. Wait, what? And wait, I just need to get the keyboard working. There we go. Okay, so a little background about this one. Like a while back, I did some internal C++ training for my company, like some beginner and intermediate training. And then as part of that, I wanted to show like what is the difference between a heap allocation and stack allocation. And in particular, what is the difference in performance by these two, like what implications does this have? Then I used QuickBench, which is a quite nifty little tool that you can use to quickly make some code examples and try to benchmark two different things up against each other. So in this one, it's like string creation and string copy. What's the fastest? You can see string creation is much faster than string copy. So that's kind of how it works. So I thought I could use that pretty easily to get a quick graph over, okay, don't use heap allocations all the time. Prefer stack allocations if you can. So I did a quick little benchmark, and that's the code right here. I hope you can read it. It's not too small. So we have a class, and then we have two different structs. One of the structs, it allocates on the heap, on the free store, and the other one we just allocate on the stack. And you might be wondering why I don't use make unique. The thing is that make unique actually zeroes out the allocated memory, and I don't want that to happen here because that doesn't happen in this non-allocating struct case. That's why we have this make unique for override, because if you use that one, then make unique for override will not zero out all the memory. Just to keep the benchmark fair, I just use the old new here and wrap that in unique pointer. So anyway, that's the stuff I want to benchmark. And the benchmarking code is very, very simple. I want to benchmark the allocating struct, and I want to benchmark the non-allocating struct. And of course, we need to write do optimize here, because otherwise this will all get optimized out by the compiler. So we use this in the Google benchmark library. They have a do not optimize thing. So it says this one should not get optimized out, because otherwise it wouldn't really make sense, any of this benchmarking. So I ran the benchmark on QuickBench, and I got the following results. And I was very happy. I proved my point. The non-allocating struct was 25 faster than 25 times faster than the allocating struct. So that was brilliant. So yeah, just what we expected. But then, of course, you start playing a little bit around. You want to see what happens. What about if we increase the size of the struct? Like, will the allocating case then get even worse? That could be a thing. Maybe malloc is pretty fast for small allocations, but what about if they get a bit bigger? Will then be even slower. So we changed the class definition here from this to something slightly bigger. So yeah, what do you think will happen? Now, I expected no real change because, well, doing a new can be pretty cheap, and doing it slightly bigger is probably also going to be quite cheap because it's just probably going to take it out of one of the buckets that it has already allocated. I thought maybe slightly slower heap allocation. So I ran this code, and this happened. All of a sudden, the non-allocating was actually faster than the allocating was actually faster than the non-allocating case. And at this point, my world just crumbled, and I got into fetus position and saying, I know nothing, and this is all wrong. But after a bit of that, I said, okay, we need to investigate what actually is going on here. So QuickBench can quite easily give you the assembly code that's getting generated by this. So I looked into that here. You see the result. I hope you can read it a bit. Otherwise, I'll just give a quick recap of what's going on. One thing I thought first could be that the compiler somehow has just removed all these calls to new and delete. But they are actually here. So it is calling new and it is calling delete. And you can see here how much of the time is spent in these different assembly lines. And you can see it's only 6% of the time. It's not that much. Actually, we have some moves here that takes a bit more. But the interesting part is down here at the non-allocating part of the code. And here we have this rep move SQ. And with my limited knowledge of assembly. I think it's repeated moves of sequential quad words, I believe. And if you investigate the code a little bit more, you can see that it actually copies from the stack to somewhere else in the stack. And this number here is actually like these two instructions together means that we're copying the entire struct from the stack to the stack. And obviously that takes quite a lot of time. And I think you can maybe see what the problem is here, that here we're copying the entire struct. In this one, we're just copying a few bytes. So in this one, we're actually copying the unique pointer itself, but not what the unique pointer is pointing to. So it's these moves that does the whole difference. So I thought, okay, that is probably it. My life is good again. And I need to know this only happens in GCC. In Clang, it doesn't happen. So that's another weird thing. Anyway, we can continue a bit. So let's fix up this benchmark. So instead of writing do not optimize of my struct, we need to write do not optimize of what the unique pointer is pointing at. I don't know if you remember, but this I is the unique pointer. Now we are dereferencing it. So we're actually saying that it should not optimize this memory that we have been pointing to. On the benchmark again and see what happens here. And the world makes sense again. Now the allocating struct takes longer time than the non-allocating struct. Not that much, because malloc can be, or new, if you will, can be very quick quite often. If you're doing repeated allocations of the same size, it's probably just getting it in and out of the same thing in cache pretty much anyway. So it's not a huge amount that is faster, but at least now it makes a little bit more sense. So there is some sane results right here. But wait, there's more. So what I tried as well by trying to figure out what's going on here was that I tried to run the original code in Compiler Explorer. So remember the original code where the allocating case was faster than the non-allocating case. So not the one that we fixed up. So it's the same code. It's the same compiler version. I think it was GCC 9.4. It was the same compilation flags as well. And the results by running this in Compiler Explorer was this. So the non-allocating was again much faster than the allocating. And comparing that to the original results I got in Quick Benchmark, it's not really the same. So here, yeah, the non-allocating was slower, but running the same code in Compiler Explorer, the non-allocating was faster. So again, I couldn't really see what the issue was here and how come these two were different. It was same compiler, same compilation flags. So it should, for all intents and purposes, give the same results. So what's the difference? And the thing is, not everything is the same. Same compiler, pretty much everything was the same, but it uses different versions of the benchmark framework. So where in Compiler Explorer, I think I used the newest version, QuickBench actually used a slightly older version. And what I actually hit was one issue in the Google benchmark code, which explicitly does this. It does some unnecessary copies of the things you call with this do not optimize. And this is fixed in Google benchmark 1.6.2 and releases after that. And I can again reproduce this if I use Compiler Explorer and use Google benchmark 161 or something lower. It gives the same results as QuickBench. So as you can see here, the allocating struct takes 41 nanoseconds and the non-allocating takes 86. So all of a sudden things started to make sense again. But it took a little while to figure out why on earth that was. But at least my worldview is sane again. So that actually brings me to the end of this talk. And what can we learn from it? I don't really know. Benchmarking is hard. In particular, micro benchmarking can be quite misleading. And you should use your own compiler to do the benchmark and your own libraries and have everything in control, and probably don't do these micro benchmarking, because they can be quite leading. And don't do as I did for real benchmarks. It's not really representative of the real world. So yes, that is basically my conclusion to this. Benchmarking is hard. Thank you.
Indeed, benchmarking is hard. And thanks, Nicola. Which brings me to Jonathan O'Connor.
Are we ready to go?
Yes.
Okay. Good evening, everybody. In 1988, I got my first C++ job when I joined a small C++ startup, small Irish company with a German name, Glockenspiel. And amazingly, I didn't know C++ at the time, but that didn't stop them hiring me. And instead, what they gave me a copy of Strustrup's book, the first edition, and I went off to learn the language. And I was amazed. This is a terrific language. I hadn't done any object orientation before, and of course, that became the big thing: objects and inheritance, and they were all so cool. But really, looking back on it, the feature that gave the most bang for the buck were constructors and destructors, and we use them for memory management. We use them for resource management. We even use them to write trace macros so that we could see what our code was doing. We could log the function entry and exit points to a file. And if you didn't have a debugger, and there were debuggers in those days, but we used them, and we got a lot of bang for our buck. And just to show you, like for instance, here's a string. It does some allocation, memory allocation, and at the end of the function, when the function exits, the destructor for the string is invoked and the memory is deallocated. And if we have a file which opens a file handle in the constructor, and again in this function, this read file function, when it exits at the curly bracket here, the close curly, the file handle will be closed. The destructor for the file class will be invoked at that point. And then here was a thing we often did. We wrote a trace macro where you could actually use pretty function, that macro, and that would make the things very easy to trace. And this would spit out something like entering foo and exiting foo, and your trace class could manage. It could figure out how far down the stack it was, and it could use indentation. It was great. So basically, my favorite C++ feature is the close curly. And I'm not the first person to use this. I stole it shamelessly from Roger Orr. And I know Peter Sommerlad has also used it in some of his training courses. But about 5 years ago, I was reading this wonderful book by Anthony Williams, C++ Concurrency in Action. And I came across this a piece of code in a section on actor-based programming. And this was the code. It left me scratching my head for a couple of hours, figuring out what on earth was happening. So we have this receiver object called incoming, and the receiver object waits for a message to come in, and depending on the type of message, it invokes one of these handlers. And you can add multiple calls to these handle member functions, and you just give it a different type of lambda, and away it goes. But I couldn't understand how on earth it decided where to invoke the appropriate lambda, and I was scratching my head for hours wondering what happened. And eventually, it occurred to me that the wait function returns a temporary object, and that you can add lots of handle. You can call handle on it multiple times, and each time it'll return a reference to the same object. And then in the destructor, which gets invoked at the semicolon here, in that destructor, it will invoke the appropriate lambda. I mean, that's just, I couldn't express my, I was tongue-tied trying to figure, it was brilliant. Amazing, amazing. So my favorite C++ feature is no longer close curly, but semicolon. Thank you.
Thank you, Jonathan. That's been an interesting take. Now, let's continue with my lightning talk, which is called compilation persistence, right? So that's something I've been thinking about. Like, you know, there's a ton of stuff which is going on with C++ language at the moment, but this is something which we don't have, actually. Compile time programming is running in a sandbox, right? And in that sandbox, you know nothing about your previous builds and nothing about your future builds and anything like that. You can write some stuff out which goes into different sandbox, like, you know, in your runtime or something, but basically you're running in a sandbox, and compilation, compile time is like just what it is. And so you don't know stuff like how often has this code been built previously. You don't have a compilation counter. You can't react on prior builds, and you can't, like, you know, save an expensive compilation which you have done in this building now for the next builds, right? So if you have a complex or expensive compilation, you will have to do it again the next time. And actually, there's an experiment on Compiler Explorer that got me thinking, which is a bit different. Because I was thinking, like, you know, can I have a program that runs only once, or just, you know, that compiles only once? And for that, an compilation counter would be helpful, right? Compile once, do something, and compile for everything else, do something else. And so I wondered if you know, I could achieve that when I delete the source file, and that actually works on Compiler Explorer. Which is the other thing I wondered, like, would I be able to test this on Compiler Explorer? Because, you know, this is a virtual environment, and maybe they have some safeguards and that I don't delete the source file, which is basically also the source file they're showing. And so this kind of works, but it also doesn't make Compiler Explorer be kind of, you know, in an unstate. So you can, like, delete the example CPP, but there's the cache of the actual source code, which again gets written. So you can modify this and run it multiple times. And yes, you can go the next step, is because, of course, you want to also remove the executable, right? So, and for that, we just, you know, need to extend this a little bit. And then we basically have achieved that we have a program which is able to compile once and run once. And as long as you, you know, directly run it after compilation, it'll be gone. And still, you know, of course, this is a bit radical and probably will not help you with your problems tomorrow. But actual persistence is possible when we end runtime. We kind of have proof with that, right? And you could then just generate your data, whatever you want to do, and post it into whatever type or thing you want to do. We've had a constant expression JSON parser. That's basically what the whole constant expression programming thing started with. That we had like a talk presenting that we could do that in C++11. And so that's kind of an approach which would be doable to, you know, write out your own header file and then include that in your build. So now you actually could build a counter, but when you want to prevent like multiple executions of your program, as we saw, you know, that's possible also. But also, I kind of think that doing this with a code generator is a bit of cheating, and you outsource your persistence to the runtime, and so on, right? But it's a step, and maybe it's a bridge too far. So at the moment, C++ does not offer ways to interact with the build system from your code, or to interact with a compiler, like instruct the compiler to cache a certain value. So we do not have like a compiler cache where we could say, here, this is what we want to cache from our code. Compilers and other tools by themselves do that, but that's out of our control when we write code. We can probably instruct CMake to do something, but not from our code. And so for the moment, that's more of a what-if thing and more philosophically thinking about this. And thanks, everyone. I think we're going to close the session with a small panel. Visible. So this is a question for Slobodan. A question on your training, or generally, what do you think is the most important challenge your students and professionals face while learning C++ while migrating from another language?
If they are migrating from other languages, the number one problem is drawing parallels between C++ and other languages. So, for example, they assume that if something works in any given language, that it works the same way in C++. So that can be really, and I discourage that way of thinking, because I think it's not, that way of thinking would just hold us down when learning C++. So my advice is that they should not be drawing parallels between C++ and any other language, because C++ is indeed in a league of its own. So assuming that something that works, for example, in any given language, C# or Python or whatever, works the same way in C++ is a bit misleading, because it really doesn't. So C++ is a huge mountain to climb, but I also like to motivate them to say that once you are you don't even have to be at the top of the mountain. You can go halfway through, and I can assure you that the view is really indeed beautiful once we start climbing this mountain called C++. So I personally find it as a thing of beauty and elegance, but that's my personal view. And after the training, something that really motivates me as a trainer is when I hear we got itchy fingers to try out all the things you showed us now. And I also like to hear that, well, C++ isn't that complex after all. That's also something that really makes my day at the end of the training when I hear a thing like that. C++ really is no rocket science, but they also like to say although used in one, right?
True. I think it's something I've experienced similarly. Actually, Jonathan, I've been wondering, what is this code actually doing? Have you asked Anthony Williams? Because that's a book I'm actually planning to read on.
What it does is it is listening. It was an example from implementing some kind of ATM or Geldautomat, and you put your card in to the machine, and that sends, when the device recognizes there's a card there, it sends a message to an actor. The actor which is waiting for these messages, and then depending on the type of message. So if you receive a card, if a card is put into the machine, your actor gets the message saying that that's happened, and it then says, okay, I'll send a message to the screen actor to say, please, ask for a pin, and then you send another message to the pin reader to actually get the pin, and then once that's happened, you send a third message somewhere else and whatever. And so the actor-based model for concurrency, I thought, was a very nice way of coding multiple threads of execution is wrong, because the actors don't. You can run actors on you can run many actors on one thread, or you can run them in separate processes or whatever. It's a very nice way of thinking about it, and also you never have, because you're sending messages, you never have data sharing problems. That was another very useful facet. But no, I haven't spoken to Anthony about his book, or maybe I have once. But like the example in the code in the book is extremely well explained. It was just that when I saw it, I didn't continue reading. I just sat down and thought, how on earth is this done?
I can see that, and I know that in a lot of books you have like a short code example, and you're like, what are they doing there?
Exactly. Yeah. And I thought I knew all the uses of destructors until I saw this, and so that's it. For me, it's just a brilliant example, brilliant idea.
All right. Let's see if there's more questions from the audience. And
while you're looking for that, Jens, I have a question for you on your talk.
Yes.
Your example of deleting the source code of your application it reminded me of the idea of Quine. I think there was a brilliant lightning talk at one of your conferences a few years ago, and somebody explained how to create your own Quine. A Quine is named after, I think, an American philosopher or logician, and it's a program that generates its own source code when it's run. So this this idea is it's fun.
Yeah, I was thinking about that when I wrote the code, or like not the code, but the lightning talk. But yeah, Quine is like the word which didn't come into my mind. So thank you for bringing that up. Yes, so that's there's the lightning talk, but also like if you look for that, there's like tons of examples online about programs which are essentially self-replicating. So basically, they print out their own code, and then I guess in theory, then you could also call the compiler in the system if it's installed, but then you kind of get into recursion and you do it yourself. So I find it interesting what all the things you can do with Compiler Explorer, and it just happens to work somehow. I hope to bring Matt Goldwald on one of those in the future, and then we'll kind of have him talk a bit about Compiler Explorer, because that's also like really a deep tool where you can install or activate libraries and do all kinds of things. Much more than what it was like 10 years ago.
Yeah, I think Jonathan Muller, who wrote the Lexi library, he has this Lexi library is basically a lexical recursive descent parser, and you create your grammar. And he has a website where you can type your grammar as it looks like C++ code, which it is, and then he passes that code to Compiler Explorer to compile, and then based on the output, he generates a graph of your parse tree of the, which is brilliant. And again, I think that's the first time I've seen Compiler Explorer used as a tool like that, where you don't really know Compiler Explorer is being run under the hood. But yeah, it's neat.
Actually, something I brought up in chat, I also quickly want to put in the video. QuickBench has a Patreon. And so if you want to support QuickBench or don't know about QuickBench, I'm not sure about it, quick-bench.com or something. But if you Google QuickBench on C++, you probably will find it. And that's an amazing tool where you can run benchmarks. It's also linked from Compiler Explorer, which you probably know as a website. And yeah, so this is run by, I'm bad with names. What is his name?
Is he French developer?
Yes, he's a French developer, lives in Strasbourg. And
Tingo, is it
Fred
Tingo?
Yeah.
Tingo. Fred Tingo.
Yeah, right, Fred Tingo. That's his name.
Yeah.
Fred, if you're watching this, thank you for your tool and support him in hosting this via Patreon. And let me once more see if there's more questions. Yes, there's one question. Let me bring this up. So a question to Nicola. You mentioned about using benchmark tools in one's own compiler build. Can you explain a bit more on this, like what feature or tools can be used?
I think what I meant was that you need to use your exact compiler, because you can't do benchmarks on Clang if you're using GCC. You have to use the exact same version to get the same results, because it can change quite a lot between different versions. I haven't done that much benchmarking, to be honest, in my life. I've done a bit, but yeah, it's very hard to do. And even when you think something, surely it's going to be faster, this in reality, it isn't, because of little intricate details in how compilers work and all of these things. I don't know if there's any specific features or any tools that you can use. In reality, you should maybe even roll your own a bit, because each application is different. So you need to try to be as close to your actual use case as possible. Like micro benchmarks, they can work sometimes, but you need to be very careful not benchmarking the wrong things. So sometimes it's better just run your program, your full program multiple times, including exercising the piece of code that you want to benchmark. I think that's a better way than to do micro benchmarking. Like, I like QuickBench. It's a very good tool. You get some ideas of it, and usually it matches up with your expectations. But you can get caught sometimes, like I did here, because I used it. I used it slightly wrong. Then I spent a couple of days trying to dig into QuickBench, how it works and everything. So yeah, I don't think I can give any specific features or tools. QuickBench is okay, but I think sometimes you kind of need to roll your own, because your application works in a special way. And I don't know if there's any. Maybe there's some generic tools that can be used for it, but sometimes it's just quicker to make a quick Python script or something and plot some graphs from there.
I've been using QuickBench last year quite extensively for just testing some basic code, and it's on my blog. So I think, yeah, you can benchmark, but it's more like good for answering general questions. And one problem which I had with QuickBench is, of course, you're limited in your runtime in the cloud, right?
Yeah.
So you can't run things twice as much. And also one thing which you always should do is what Nicola has been doing, just question if your results are actually as good as they should be, or maybe they're too good. Maybe they are in a way that you question them, and then you find out that you are running on the wrong version of QuickBench, which I find kind of hilarious that they have this bug where they copy things.
Yeah, I actually realized that only today. A couple of hours ago, I found out, that's why. But also, while QuickBench actually, it doesn't give you absolute times. It gives you relative times between two things. And that's exactly because it is running in cloud. So you can't really, you don't have a dedicated CPU. But that being said, you can run it locally, and it's very easy to set up actually. So go ahead and do that. It takes no time at all. Then you can just run it on your own computer, and then you will have a dedicated CPU to benchmark it on. Yeah, but when you are at that step, I find maybe it's not, if you need something to be as accurate as to it has to run on one actual CPU uncontested, maybe it's not the right tool. I think it works well enough, QuickBench, just the online version, and get some relative benchmarks, because you want to know, is this faster than the other one? You don't want to know, oh, this does in 10 milliseconds. That I don't think it can be used for, and that's not how it's designed anyway. So
yeah, it's for benchmarking or for micro benchmarking. So I think, like, you need to try to get a minimal working example of what the thing you want to benchmark, and like performance in an application is a whole different thing, because like, even if you benchmark and show that something is faster, then in your application it can be the thing which actually eats the performance is something else. So maybe you make your code 50% faster in a micro benchmark, and then you put it in your application and you find out that nothing has changed, because the code you made faster is now just waiting longer for the other code which needs to finish things. So
yeah,
they are
uses
looking into tools for flame graphs to see where you're basically spending your time in an application.
And also maybe your hyper optimized code makes other part of the code slower. If you start to use L3 cache or something like that, which is shared between all different cores, maybe it has maybe that part of your code that you've hyper optimized is very fast, but something else all of a sudden that suffers. So the net effect is that your code is slower. So yeah, you also need to have a benchmark of the complete system at some point.
Right, and generally there's a good comment from LinkedIn. The compilers are too good today and better than the benchmarking tools. And 20 years ago, you just went on with 80-20 rule and wrote relevant stuff in inline assembly. I think that's a lost art, and got your boost. This is completely different nowadays. Yeah, I think that's a true thing, which you also have to have in mind today. That you can benchmark things, but then also have to ensure that your benchmark measures the right thing.
Or sometimes, Jens, the last time I did any benchmarking with Catch 2, which has benchmark support, and I had a vector of names like John, Mary, Jens, and Jonathan, and I wanted to benchmark the COUNTIF algorithm, and I did, okay, how long does it take to count how many names are Jens and how many are Jonathan, and I expected that counting Jonathan's would and Jens is only 4 letters long, and it was completely the other way around. And it took me about an hour to figure out that the string equality operator doesn't check the characters. It first of all says, are the lengths of these two strings the same? And if it isn't, it immediately aborts. And
no, it doesn't.
And as most of the strings in my vector were 4 characters long, but Jonathan was 8, so searching for Jonathan was much faster than searching for Jens or John or Mary. Again, you get these surprising issues cropping up, and you're thinking, "What on earth?" And then you feel like an idiot. But
I think we've all been there.
Yeah, definitely.
Actually, that gets me back to your lightning talk, Jonathan.
Mm-hmm.
You have this example with a string Jonathan, and you're like, saying, "Oh, this is an allocation." No, it's not.
Yeah, okay. I did. My slide wasn't big enough to avoid the small string optimization.
That's the other thing which can bite you, and you do your benchmarking, and your real code actually contains real strings, and the benchmarking is just on smaller strings.
Yeah. When did that get introduced? The small string optimization. Maybe you're using a different library that doesn't do it. So you have to use the exact same thing to do your benchmark.
Yeah, definitely.
Yeah, no, that's not globally used. I think that's something I haven't been able to prove. I've been trying to, do a type which has a string view and as a union or a variant, and then something which is as big as a string view to see if small object allocation or optimization for string view would work. But there it seems like that string view is better directly used than having this indirection. But I'm still not sure, maybe there's some weird corner case where that would be a better optimization or not. But anyways, there's a detailed question which I'm sure Nicola knows. Is Google Benchmark used on QuickBench? Do you have some experience in using Google Benchmark locally? Is it hard to implement?
No, I have not tried to use. The QuickBench uses Google Benchmark, but I have not tried it locally in any of my code. It's only because I wanted to have something quick for that. What was I was teaching the C++, as I said. I want just to show this, give a proof of concept that okay, it's actually faster to allocate on the stack than on the heap. So yeah, quick benchmark sprung to mind. So I thought, I can have a nice graph showing it. That's always nice. But I haven't actually used Google Benchmark myself too much. I've usually been doing my own scripts to do, but I don't think it's particularly difficult to use Google Benchmark. I don't know if it's probably not header only, but I think it's fairly simple to include in your project.
Yeah, I guess there's a ton of examples, and probably one talk about it from CPCon or something online.
Most likely, yeah. Or a nice getting started guide, probably.
But give a shout out to Catch 2, because it has support for benchmarking, and if you're already using Catch to write your unit tests, then use the benchmarking support there, and you don't have to worry about extra libraries. It'll do more or less the same thing as Google Benchmark, and yeah.
But how? So you write a unit test basically, and then it just benchmarks the unit test, or how is?
No, you write again. There's a macro where you say benchmark and like test case or whatever it is in Catch 2, and it creates some kind of lambda that's run.
Okay, so is that kind of to have a non-functional requirement test directly in your unit test? I'm just find it a bit odd that a unit test framework suddenly have performance profiling.
I don't know why they did it, but they added it in quite a while ago.
Yeah. Okay.
Occasionally it's nice. I mean, and also I don't mix benchmarks and unit tests in the same source file.
Oh, that's also what I was wondering a bit, because benchmarks are a bit brittle, I would say. So I found it a bit odd that they have. But yeah, sure. If you're using Catch 2 anyway, then if you just want to do a quick benchmark of something you've done, by all means, I think that's it's good to know.
Yeah.
True. And I think that's one of the advantages of QuickBench, that just something comes to your mind, that's faster, or is that faster, then you just can easily set it up on QuickBench. as long as you don't need to include some libraries or something. So I found it kind of interesting that Jörg also kind of play around with this on Compiler Explorer. Then you don't get the nice graphs, but you get to use, I think, a lot of the libraries which they have installed, and then you could test your ideas with libraries.
Or maybe there could be made a plugin for Compiler Explorer that could show those graphs if you are running it with the QuickBench library.
True. That might be a future.
If you have some spare time, you could you could try to implement it.
Yeah. I know that Matt Gottbold is right now toying around with a lot of stuff and having some free time, so let's not give him the wrong idea. But actually, we have QuickBench for that, right? So
yeah, that's true. That's true. Yeah, and it's linking directly to it. I think it also copies your source code, right? Doesn't it?
Yes.
Yeah.
And the other side, this is like 3 pages which link to each other from each other, and the other side is CPP Insight from Andreas Fertig, which shows you basically how all the intermediary C++ which is generated from lambdas and other usages in C++. Which I think is like really, really good tool when you're teaching, especially like beginners, to show them that lambdas are basically in place classes which generate a lot of source code. And I remember like people at CPPCon not being too happy when I pointed out that lambdas and all the other for loops, etc., which we have now in C++ 11 are essentially macros which do text replacement, and then your code gets compiled. And
Jens, that's actually what I wanted to ask you. How did people react when you held the talk? I watched it online, so I was wondering immediately what was the reaction in the audience when you presented that talk?
It was. I thought that at least it was an interesting reaction. So I started about macros, and I talked about macros, and that we should modernize macros, and that we should have macros in the language, etc. And that was the hard part actually, because I was like, the audience was like almost like on the verge to booing, right? So they didn't. So thank you for that. But when I asked like, who likes macros, and then like basically there's an absolutely non-reaction from the audience. That was kind of scary. And then at like some point, someone, I think it was Tony or something, like yay, I like him or something. And then we went on, and in the aftermath, I think I got like so one of the goals was, because CPP Insights was kind of new, that I wanted to have this tool be more visible to people, and also to kind of show like what's beneath those features which we have now in the standard. And so I kind of like that, I also kind of was trolling the audience, of course, with that question, like, if we should have something like that in the standard, and nobody raised their hands. And I'm like, well, actually, it's too late. We already have that. Like, look at lambdas. That's what they're doing. And here's a tool where you can look at it. And I've got a few people after that, finding me at the conference and telling me that they like the talk, and that the tool is kind of useful to look at C++ in a different way.
Right. So one thing I should also add, back to the question regarding the learning C++, I should also emphasize that C++ is one of those languages that really can't be learned by guessing. So while some other languages might be learned by guessing, my personal advice would be that you don't try to learn C++ by guessing, because it is very involved language. It is complex language, and you really need to have a proper guidance and a proper learning path when learning C++. So also one advice that I would like to emphasize is that people should not try to learn C++ by guessing. So that would be also one of the advices I should put out. Okay.
I agree with that. And I think it's like, you never finish with learning C++, right?
Indeed, correct.
So
Which is also nice.
yes,
You can always learn new stuff. That's always exciting. This new fancy feature we're getting.
and that's actually kind of what I'm doing right now. Is I've tried to get a mentoring program started or thinking about it, and right now I'm talking to people about like what their expectations are and where they're coming from, and I learn a lot about how they learn, and that basically the newer generation has like a completely different ways how they learned, like which is maybe really foreign to like folks from my generation, like learning through online courses on Udemy, but I primarily learn with books and over communities. So that's interesting. And also kind of to see how different people like, have different ideas about learning and what to learn. All right. I think that's for the moment regarding questions it. So thank you for coming, Nicola, Jonathan, and Slobodan. And with that, I'm going to end the live stream. Thank you for coming, and
Thank you. It's been a pleasure.
Thank you, Jens.
Jens. Thank you.
you're welcome.